Well, good evening, everyone. A warm welcome. Thank you for coming out this evening. My name is Adam Hems. I'm the leader of this group. This is one of my hobbies. I've been running this group since 2015. So I see a lot of new faces tonight. New faces? New people. First noobs. Not like this. Noobs. There we go. Yeah, there we go. A warm welcome. Warm welcome. Not very enthusiastic in the front row right there. That was kind of, there we go. Thank you. Yes, thank you. Yeah, it's all good. It's all good. A really warm welcome. So this group is, like I say, it's a hobby of mine. Took over in 2015. I do it with a lot of help from colleagues like Kim and her family. She's a speaker, a colleague and a friend who helps out with help of her sons. Her sons were the ones who greeted you all when we came in. And so, again, it's a team effort here, so with a lot of help. We run this, try and do it every month. Second Tuesday is what we're targeting. And the focus of this is about learning from the speakers, right? This is about sharing journeys. Ideally, some of the best ones have been from members of the community where they've come out and shared their stories, their learnings, good and bad, right? This is what worked, this did not work, just stories. Because certainly my day job, I spend since I've been in this role as a cloud architect for Microsoft during the day since 2015, and I spend all day, every day talking about cloud to individual customers, but there's never an opportunity for users of cloud at different customers from different backgrounds to talk to one another, right? And so that is one of the areas of focus here, learning from one another as much as from the speaker. And it's very much not about a sales pitch. If you're here for a sales pitch, if you're here for a comparison with friends in AWS, it's that one, right? That building, yeah, wrong place. Yeah, we try not to conflict with AWS Meetup. In fact, so it's all good. This is about learning, not about sales pitches or anything like that. So that's what we're about. So tonight, for those of you in person, I wanted to call out that our food is, oh goodness, we need to turn it down. Speakers need to turn down a bit. Oh, I'll try that. There we go. Oh, for those of you in the room, number one, the room is now mic'd, so there are mics at the back of the room. So any quiet conversations you might have, in the back there, remember the mic's behind you and they can hear you online. So don't do that. Yeah, just FYI, right? You're trying to have a quiet, private little discussion back there. Yeah, you need to go outside to do those. Otherwise everyone online is going to be listening too. Right, number one. Number two, we have our sponsors tonight, our newer Desic. They paid for the pizza tonight, and we're grateful for that because otherwise that's nice of you. Thank you, new Desic. Really appreciate it. In fact, they're up front right here. Did you guys want to say a word, or we just want to say thanks? What, do you want to say something? Yeah, here you go.
Hey, everybody. Just wanted to let you guys know a little bit about Meetup real quick. We've been in business for over 20 years, doing work in various different practices, from custom app dev to SharePoint, data and AI, and even management consulting. That's where I come in. I'm actually a management consultant for Meetup, going in, doing that business requirements gathering, all that stuff that helps us with the dev side. That's mostly what I wanted to tell you guys about, and just kind of what we do and where we do it, if you will.
Okay. Thanks once again. Yeah, appreciate it. All right, so I'm gonna flip to, I'm gonna stop presenting so your stuff comes up, and then I'll hand it over. So you're all here to hear about Windows 11, right? And some of its new features, because it's cool. I'll tell you, there's a lot of cool stuff in that thing. Have you seen the new calculator in that guy? Because you're going to hear about it tonight. I know that's what you're here for, right? No? AI is, of course, what we're all about. Everyone, it's the buzz, and so that's we've Actually, we've spoken about AI before. We had a discussion in January about some of the preview of some of the features you'll hear about today when it was first announced, but really before much of the hype had hit. So many of you missed it because the hype machine was less in full flow all the way back in January 2023. I was like, how long ago was that? Forever ago. Who even remembers? No. But yeah, we did have a good presentation about some of these early features. But, well, let's say that momentum has grown, interest has also grown. And so that's why I felt this was a good time to talk about not just some of the AI features, but another favorite topic, how they might be used in custom applications. So we have a double set of presenters tonight, starting with Seppa. I'll hand over to you.
Hello, everyone. My name is Sefer Pakbaz. I'm a cloud solution architect at Microsoft. My focus is in app innovation. I've been a developer for 22 years. My colleague.
Hey, everyone. This is Yushin. So I work as a data AI cloud solution architect at Microsoft, mainly focused on the AI services. So, yeah. Welcome, and this is my first time to present here, and looking forward to have more opportunities to share some experience with you. So I'm going to kick it off, and today we're going to focus on the ChatGPT. I'm going to first give an introduction of the ChatGPT and some Azure services, and later on we can come with more demos and use cases. So first talk about the history of AI. So back in 60s. So we do already have some artificial intelligence, the scientists, they start to kind of doing some research on that. But by that time, it's more like a symbolic. So it's like some kind of rule base. So the scientists trying to kind of code it some like the machine is trying to make the decision and trying to move to the next step. Later on, so we have this called machine learning. So you may familiar with this. So for this machine learning, we have different type of kind of algorithms, for example, supervised learning, unsupervised learning, reinforcement learning. So for the machine learning, a concept.
1 sec. I'm sorry to interrupt, but we've lost presentation on the Teams. Could you, I don't know, unplug and re-plug back in? Teams doesn't catch it.
It was something.
It was something. It was working great. Honestly, it was working great. Really.
So we just have to unplug and
Try that. No,
We need to join the team. We need to join the team meeting.
no, just
soon AI will solve it.
The AI didn't want you talking about it.
And we're back.
All right.
As you were.
Okay. Cool.
Great. For machine learning, so this is like a so for example, when I was in the college, this machine learning is we kind of have a data slice, and then we kind of label the data slice, tell the machine that this image is about apple, that image is about orange, and then we kind of train a model, and then we deploy the model, use that model for some kind of prediction. And also we have this deep learning. So deep learning, this is a very kind of deep networks with multiple layers. But for deep learning, this concept of this technology is available around 2000. But why it's kind of make it more popular in 2017? That's because by that time, the hardware, especially the GPU, is able to power up this deep learning. So now for today's meeting, we're going to focus on this called generative AI, especially the GPT model we're going to focus on. So the generative AI, the model's focus is by just a given, it's able to create it, not only the text, but also the images and other information, but just based on a few examples we're given. So we don't need to train a model. So we just need to give maybe a query, and then this model is able to generate you a email, generated even a book, or generated images. So two types of models here. One is called generative model. This is something we can use this model to generate some new images, generate an email. Another is called like discriminative model. So we can use that model to do some kind of classification, sentiment analysis. So for this generative AI, so what we can see is by using one model, we can achieve multiple tasks. So before, if we want to do a classification, I want to do a sentiment analysis, I want to identify apple and oranges, I need to train different models, and I need to deploy a couple of models to achieve each of the tasks. But now, using the single model, we can achieve like all those tasks. So that is a history. And you may see like now the AI are grabbing like a lot of these headlines. And for this generative AI, especially the GPT models, so today it has been integrated into a lot of like Microsoft services. For example, so you may already realize that the Teams is already have integrated this. It's able to kind of give you a summary of your meeting right after you kind of end your meeting. So this is like the OpenAI, how the Microsoft today is like collaborate with OpenAI. The two companies is going to like developing the new like AI technologies. So keep releasing the models like the GPT models, the ChatGPT models, or even the DALL-E model, sorry, to generate the images. Also, like they kind of collaborate to build the computation platform. That is also very important. So we need a lot of GPUs to support this like large language model. So today, there's, as you can see here, I listed a couple of models there. So we have the GPT model 3.5 and GPT-4. So this mainly like deal with the text. Also, we have this called ChatGPT model. So it can be used in like a conversation use case. Codex model. So for this model, we can use it to kind of generate the code, understand the code, or even translate the code. So as a data scientist, so I like mainly use a Python, but if you want to convert it to a like C# code, we can use a Codex. Or if I kind of take over some code, a long code with no like documents from another developer, it will be very helpful to use this model to generate like a documentation for you. DALL-E model, this can use to generate some synthetic images. So just show a couple of examples. Yep. And one key here is called prompt. So prompt is like we tell the model what they are going to do. So it's like a large model. So we can just give it one prompt, like for example, create an email, write a tagline, or even like create like an HTML website for me. So it's gonna give you the response. Similarly, for a ChatGPT or conversation model, when you're talking with an agent, it can take all your conversation as an input and trying to use that to kind of give you the right response. Similarly, we can use that to generate some code, do some code conversion to write you like code documents, or we can ask it to generate some synthetic images. And we're going to talk more about the use case later. So let's go to the. Thank you. So the Azure OpenAI services. So what is the difference between the OpenAI service and the Azure OpenAI services? So all these models you can see, which I just introduced, is available in Azure. And in Azure, we will provide you enterprise-graded level of security. So people ask a lot of questions. If I use my own documents, whether the documents will be used to train the model, or whether like the prompt I read will be like available in the open public, in the open internet, or like be used for the training, or like all the type of security questions. So in Azure, so each of the model will be deployed in your own tenant, and it will provide the enterprise graded level of security like other services. So if we go to the next slides, so I really would like to show this. This shows the AI offering in Azure. So as you can see, the Azure OpenAI services here is part of the cognitive services. The reason is like this large language model, if you think that is it's just a model. So you input a text, it's going to give you some text response. Or if you give a text input, it's going to generate an image. But how can we kind of build an end-to-end application? But by just use OpenAI services is not enough. So you really will combine multiple services or even multiple AI services to build end-to-end application. So just give a quick example, and we're going to show a demo later. So for example, I want to build a call center use case. So we know this model is very powerful. It's able to understand the conversation between agent and customer. But how can we capture that conversation? Because they're talking like in the near real time. So in that case, we can use some other like AI models, like for example, the speech model. So this will capture that audio, no matter what language it is, and convert it to the text, and then translate to English, feed it into the OpenAI model, and generate user results. So that is like one example. We have other examples. So the Azure AI offering actually cover a lot of those type of services, which we can directly use to kind of quickly create an end-to-end use case. So I'll not spend a lot of time here, but just give a very quick overview here. So for the cognitive services, we have this different we kind of have the different family. For example, the vision. This will focus on the computer vision. It can do like image classification, object detection, or it can do like facial detection, spatial detection. For example, we can add this model like in a camera, and it can like count the number of people in the room in the near real time, or it's able to calculate the distance between the two people. So those are all some kind of pre-trained model. Speech, the speech families has some like speech to text and text to speech conversion. Language model is doing like some natural language, like for example, name entity recognition, and like k-face extraction, sentiment analysis. Decision model, this can do some like time series analysis. For example, it can do, for example, I can use this model to input some IoT devices like ratings, and then it's able to like tell you whether there's any potential issue for this device. It's like can do some predictive maintenance. So all the services today has already been integrated into the application level. So from the Power Apps or from the Power BI or Power Automates, or even the Microsoft Dynamics 365, all the AI services you see today comes from these layers. And OpenAI, of course, is already started to integrate into those service Microsoft products. So the next question would be, when should we consider to use this OpenAI model? This OpenAI model is very convenient. So for example, if I need a general purpose model, as I mentioned earlier, so I want this model can do not only the sentiment analysis, but also can do some like key face extraction, also can do some classification. So I don't want to train a couple of models. And then this will be like the general purpose model will be a good choice for you. Second one, like if you want to do a fast POC. So I have some data and I want to first prove the value and go to market quickly. So that could be a potential use case. Third one, I don't have a lot of training data, and I want to start to use it, or I don't want to train a model. Then I can start to use this model. Another use case is, for example, I want to generate something. So that is actually like a use case we're working with the customers. So they want to train a model, like a image classification model, but they don't have enough training data. So because they want to do some like anomaly detection, for example, oil spill or those type of things. But that scenario is not common. So it will be hard to collect a lot of images like that. So in that case, we can use this large language model using the DALL-E model to create some synthetic images, which use like actual images as the base. So in that case, we can use, it's like a data enrichment use case. We can actually use that to create more training data to help you train on like image classification model. And usually this model will combine with other services, and we're going to show a couple of use cases later. Okay. So about the security. So the data. So the question when like most people ask is if I bring my own documents, because this model has been trained on trillions of documents or trillions of data, whether this data will be used to train that base model. So the answer is no. So in the Azure cloud, when you bring your data, that data is like always will be encrypted. That's the first thing. And second thing, this will be not used for the model training or train your base model. And the third thing is like, as also mentioned earlier, this is all like encrypted all the time, and it's protected by the like the enterprise level of like compliance and security. So I'll quickly talk about this as well. So this is like the Azure OpenAI Responsible AI. So we want to make sure like people are kind of using this securely, and also not trying to ask any like harmful questions, or not getting any like harmful content. So in that case, Microsoft also developed that like the responsible AI model in XAML, as you can see there. So for this model, it's able to kind of detect any harmful information. For example, if you're asked a prompt like how can I launch a missile, some question like that will be actually like automatically detected and will be like log it and filter it out. So you will not get a response, but your manager may get that. So that is kind of a responsible AI models like developed by us. So for this is like we can talk more about in the Q&A, but this part is more like a mitigation layers, how to make that model more like secure and better to use. So in that case, so first of all, from the base model perspective, so we're doing a lot of fine tuning to make sure like some of the questions will not be answered. And above that, so this is like the filtering and monitoring process. And in that case, because we cannot control how people ask the question, and in that case, we have a model like able to detect any questions or any prompt that includes some harmful information. Also, there's some guidance on the even higher level when we kind of develop an application of what we should do, right? So how we kind of design the prompt, how we kind of better educate the people how to use it. And those are type of things. We have a lot of details here to like.
I was going to ask on the detecting abuse. I mean, there's obviously things like missiles. I work for a refiner, for example. So if somebody was able to access the data to say, how can I bring down a particular unit because maybe they want to sabotage something, is that something that it would pick up, or how does it? Yeah. How does it know in terms of what qualifies as abuse?
Sure. So so from the model level, so this is like even the base model. So how they're gonna do is so the data scientists, they kind of have some like validation data set and ask the model to answer those questions and use that to do a fine tuning that is at the model level. And on the safety system level, so we also have another model that is an example model as I just showed earlier. So when we ask a question, so in that prompt, it may include some harmful information. So that model is like the second layer of protection, is able to detect that information. So for example, whether it's related any PI information, whether it's related any harmful information. And from there, if it detect that, it will kind of filter it out. So it will not even reach to the model and like trying to get a response or get an answer. On the even higher level, from the application layer or UI user interface level, we can also have a control. For example, what type of question the user can ask. So this is like this slide is show like the different type of mitigation layers from the model level to the system level to the application level. Like how can we better like make that application more secure?
And it needs human oversight in each of the stages. Yes, no?
Human oversight is actually here. So that is a log. So we will log it here. So here is more at the design level. And at this level is like the base model is going to also do the fine tuning. Yeah.
Does the safety system apply when you do like an LLM, for instance, and integrate it like with LangChain and Hugging Face and any other?
Yeah, so this is like the Azure OpenAI. So if you use Azure OpenAI API, so for the safety system and model, it's all applied there. Yeah, if even you use a LangChain tool.
But I suspect if you ask what causes leakages to heat exchanger that feeds into the distillation column, it's going to answer. That seems like a non-harmful question, but it can teach how to cause things.
It's interesting implications for sure.
Not much you can do about it.
So there's even like a, so there's even like a, for example, for a knowledge base, which Cyber will show later. So there's also some other controls. For example, if I have the access to document ABC, but you only have the access to document A, if even we ask the same questions, we can control the number of documents kind of return it back to this large language model. Those can be controlled by the different application.
Yep.
Who sets these all these mitigation layer? Who sets? Is that like a user setting all this?
No, the mitigation layer, so user can set on the top two layers, like UX or UI and application layer. The monitoring layer, that is a Microsoft built another like a round of another model trying to protect that. And the fine tuning is like the data scientists where they release that, like for example, GPT 3.5 or GPT-4, they already do that fine tuning to like make sure like the unsecured or harmful question will not be answered.
Doesn't that inherently kind of build in bias into anything? Because say a corporation could effectively then use that for releasing information. But if you look at other countries, shall we say, that may not want to give people the information, you can restrict people's, even simple questions, you can restrict the kind of information that people are getting. And not just things like how do I make a bomb, but you could have all sorts of things restricted at that stage. So aren't you inherently building in a bias on the kind of...
Answer that. So there are some levels of inclusion and fairness in the model itself, but depends on your application and where you serve the application. There are other things it can do, which I will explain in a minute, that you can essentially customize it per application basis.
But the Microsoft policy, would that be the same, say, in the US as in China? I'm thinking.
Right.
Would they be different? You would have a greater restriction on the information that you could get out of it, just inherently by governmental policy at that stage.
So, I don't know about the political thing, but as far as like the inclusive and fairness, and there are some charts that they actually have a tool. Maybe we can show at the end that they actually you can configure it for things like inclusion and fairness and other things that you can apply.
Okay. Are there things you can get through the OpenAI API that you cannot get in the Azure OpenAI service? Or is there differences in the API?
So the OpenAI and Azure OpenAI, the base model is the same. The API is a little bit different. So the Azure OpenAI will apply those like, for example, the filtering capability. Also, it will like have that, for example, security check. So those are the many differences. But the base model, for example, GPT 3.5, GPT-4, the base model is the same.
Yeah, I got the model. I was just wondering if there are things you can do in the API that within OpenAI that you cannot do in Azure service.
It's the same model. They're actually using Azure. So.
Good question. So we keep talking about the things it can and can't do. There is a limitation based on guardrails. At what place are the guardrails applied, or can the architect of the software, the implementation be applied?
What I'm going to talk about next.
Perfect, because I think that's what we're all talking about, and I think we're just waiting to get there.
Just
Sorry about that.
Yeah. All right. Any more questions before we? All right. So you see the news like from Build and other places that there are like co-pilots everywhere, co-pilot for Windows, co-pilot for this, co-pilot for that. And it's just like a mushroom popping up everywhere. It's like how does Microsoft can develop all these things so fast? It's because, thank you. It's because they developed the co-pilot stack. The co-pilot stack, you can think of it as a traditional 3-layer architecture, data layer, business logic layer, and UI layer. It's the same exact thing. The bottom part is the foundation model and infrastructure. That's going to be your data layer. The middle part is the AI orchestration, which does some safety things. I'll get into that, and the application layer, which is your user interface layer, right? So for most of the parts, you don't really care about the bottom one unless you're a platform company like Microsoft. You can customize it, of course, but for most of the parts, your application is also the same. Your UI is going to remain the same. The middle part is the one that you're going to work with. So as you can see, this is now like the bigger picture of it. So we have, as you can see there, AI safety from the all the way through the stack, from the bottom to the top. We have this orchestration layer. On top, we have the front end, if you can do next. So we have the user experience, or UX, right? So this is going to be initially, you're going to see some, like a panel on the side. So it's going to be like a side panel. That's kind of like a co-pilot. Eventually, it's going to be more emerging into the application. So that's going to be from beside your application to inside the application, and eventually going to be outside of your application, meaning like there's an orchestration layer that control multiple apps. Like, for example, what Microsoft is doing with Microsoft 365 Copilot, which is going to be connecting multiple apps through some orchestration layer. So in the middle of the stack, this is where you want to spend your time, because again, for the foundation model, those trainings will take years, and it requires special hardware. So you don't really want to spend your time there. You want to spend your time here. You can do a lot of things here. So not only you can have access to what goes into the model, you have access to what goes out of the model. So you can manipulate all of it. So you can, there's a process called grounding. Click next. But before grounding, we have this prompt and meta prompt. So the way that these models are trained is that they fine-tune the model with the prompt that they added. You can do it with something called a system prompt or meta prompt. So you essentially instruct the system to do specific things. You can tell it, for example, to just to be helpful, or you can train it to be just answer some questions based on some sources that I provide, and do not answer anything outside of these sources. Essentially, do not hallucinate. And you can take the prompting. And this process of grounding, they call it RAG. It's a retrieval augmented generation pattern. So the grounding is the way that we can essentially intervene with these models. So there's this thing called vector databases that, I give you an example. For example, the way that the Bing AI works is that you put an input. Obviously, some of this information the ChatGPT doesn't know, because their information cutout is at the end of 2021. So what it does is first uses the Bing API to retrieve the information from the search, and then give that information as a vector database to the ChatGPT model as an input. Or some other plugins or web API calls, and that's a pre-grounding. Then it goes to any other plugin extension that it has, and the result of it goes to, click next, it goes to the foundation model. And this foundation models, in case of the Copilot stack that Microsoft developed, they thought about it in advance. They don't just use the OpenAI model. It can be used either using the hosted model, which is the OpenAI model, or the fine-tuned version that they have for the purposes, or you can use even the open source model like Hugging Face and others. So they thought about it, and they put it right in there. So if we click next. So this is the whole stack, and that's why it's important to understand. As you can see, the grounding and plugin execution, you can think of it as more like a middleware. So what goes in the same order, in the reverse order, goes back out from the model. So the response comes back from the model to the plugin that essentially can be applied on the result. So not only you can control what goes into the model, you can control what comes out of it, and you can essentially massage it whatever you want. So to answer your questions, for both safety and for localizing the application for specific area, right? You can use these techniques easily to kind of like manipulate it, and you can use Web API, for example. So this is where you can actually, as developers, you can jump in and do other stuff. I'll show some demos on this.
This is similar to the GitHub Copilot.
Yeah. Yeah, so yes, so they used, obviously we don't know exactly how they use it. I mean, GitHub Copilot, but they're using similar stuff. So yeah, the sky's the limit. There's a lot of capabilities in this limitless generation with few lines of input. So if you can go next. Some of the examples, some of the use cases is going to be content generation that y'all seen from the ChatGPT, right? The summarization is something that you can actually use, and my colleague will demonstrate later in a call center demo. The code generation is what you've seen in Copilot for GitHub, and semantic search, which is essentially just it. And you can combine these together. So if you can click next, you can do, like, for example, end-to-end call center analysis using the classification, sentiment analysis, entity extraction, summarization, and email generation. So some of this we can be using models from OpenAI, but some of this is going to be just using Azure services like cognitive search or text to speech or speech to text, etc. So this is, yes.
Just a quick question on the semantic search. You guys have a lot of documents in SharePoint. Are you going to be adding same type of search capabilities on top of SharePoint? What is it? You're into a vector database?
Funny that you mentioned it. I just had an exact.
Because it is different, right? I mean,
some customer today.
You either complement it or
right.
Are you going to expand?
So like a AI service called Cognitive Search. So that service comes with like a tool called Indexer. So the indexer is able to kind of monitoring on a specific data source, and it's able to, like, you have new data, it's going to index it in the Cognitive Search. The Cognitive Search will be your knowledge base. And to the SharePoint, there is a SharePoint indexer, so you can set it up. So the end-to-end is like, for example, when I have the new documents in the SharePoint, then it could be indexed into Cognitive Search, and then we can use a large language model to search from that and answer the data. So even better is this Cognitive Search comes with something called SKUs. SKUs is like you can bring your own models, or you can use some AI services. For example, we can use a vision API. We can use like a natural language API. Like in that case, you can do some data enrichment. So if I have a PDF, we have something called form recognizer. It's able to crack the PDF, extract the documents, use some images. It can process an image, like classify it, add additional fields, and index into the Cognitive Search for your knowledge. So all that can be set up and can
So you're not dumping it into a vector database then?
Cognitive Search is a combination of vector database and text database.
Okay. Thank you. That's interesting. Didn't know you had all that going on.
Well, I literally had a conversation with a customer today about this same exact thing.
That can be a demo later, or?
Yes, it will be. Yes.
Excellent.
Yeah.
All right, so you can just actually do quick. So this is one example for the enterprise data sources. So often asked that, okay, am I the owner of my data? Am I in control of like my own things that goes into the OpenAI? Absolutely yes. So the good thing about the Azure OpenAI service that it's yours, it's in your tenant. Not only is yours, everything else that you deploy alongside with it is yours. So in this case, for example, let's say you have a document library that is maybe confidential data or something that is specific to your. You use the Azure Form Recognizer, which you may have known about. Like this is a service that's been there in Azure. It scans the document, it reads the text, OCR, does read the tables, extract information, pair information, and you can chunk it up either by pages or by chunk sizes, and you can store it in something like, for example, the Azure Storage, which is, again, yours. And then use the cognitive search to index it, and using that index to get these information or search this information and feed it to the OpenAI, because OpenAI has the reasoning capability, right? that is the part that we're going to be using. The problem here is like OpenAI, you cannot just feed all the documents to it. There's a token limit, right? So you have to chunk it up, and you cannot just give all the chunks. You have to give like the ones that are more relevant. It's like having a 1,000-page book and you want to like take an exam. You just find the chapter, you find the pages, and then giving these pages to the OpenAI, and it will figure it out for you. So I have a demo for you on this one.
How effective is this model of structured data in tables? Financial data.
I will show it to you right now because I actually happen to have it right here. So I have two demos. I have one that is a stock demo. You can use it. You can see it on GitHub. It's a Northwind Health Plan Plus. It's like a bunch of employees benefit paid documents that you can upload it, and it will answer your questions. For example, it says, does my plan include what is included in the Healthcare Plus that is not in the standard? I don't want to read all those pages. I just want to answer, and it gives you the answer right away. Not only it gives you the answer, but it gives you the citations. If I click on it, it will open the same page from like hundreds of pages that is there. That the information is there. You can verify it. So one thing is interesting is that if you click on the thought process, you can see that what it's searched for. It's actually take your query and it's searched for something that is more concise. And so, for example, you can have a typo or putting something verbose, but it will make it concise and give it to the prompt. So give it to the search, Azure search. The Azure search will now get this information. What happened to my screen? So look at this meta prompt. The meta prompt says, please help employees with their healthcare plan. Answer only with the facts listed in the sources below. If there isn't enough information, say, I don't know. So basically saying, do not hallucinate, do not mix stuff up. Just answer the question from the documents, not just making it up. So that will fix that hallucination problem. So and you can see the sources are listed below. Again, it will be carefully put it so it doesn't exceed the token limit. And then it will just pass it to the OpenAI, and OpenAI take all this and will give you this answer. So this is where OpenAI is shining because it has the reasoning capability. It can extract all the text and it gives you exactly what you want. So I use this one. Yes.
You've used hallucinations twice. I know what it means, but I don't know if everyone else does. So can you explain what a hallucination is?
Okay, so for hallucination, you may have read all this article that these information from these ChatGPT and other sources they're not accurate. They're just making stuff up. They call it hallucination. It's the term that they use, right? I'm pretty sure there's some more technical term for it, but that's the term that everybody's using it. The reason for it is that these are not looking for the fact. It's just looking for giving you the information that is best, statistically possible to the next word, right? So basically putting words together. But if you give it a meta prompt like this that said, do not use any other sources, just use the sources that I've given you, that's the chance of hallucination is going to be substantially dropped. It's not going to be zero. Again, it's like in mathematics, there's nothing 0%, but it will be substantially dropped. And that's, thank you. So I just used this one and I opened another, I created another one. It's the same exact application. I just made a few changes, uploaded different documents, uploaded the IMF report for the economy, for the world economy, and then the other sources. So I'm just asking, what's the world economy going to look like in 24? There's no way that ChatGPT can know because the information cut out there is from you. So this says according to the IMF, it says grew by 3% in 22. So if I, for example, ask another question, it's going to be a recession, right? So it says, yes, it's going to be a recession. So for some reason, it's not showing you the citation, but it's going to be actually getting that percentage from a table that you were asking, like how accurate is this, that this information is coming from a table from the IMF report.
Thank you.
Yeah.
So questions online?
Okay.
Are there going to be any offline solutions using Copilot plus a custom language learning model?
I don't know the answer to that.
Offline solution? What is offline?
Offline. I think it means disconnected.
Disconnected from anything, for everything from even Azure,
Yeah.
or private.
Right, private, yeah.
Well, you can do the private connection, but not offline solution. But, well, I'm going to hand it to my colleague for the next demo.
I got a question on the large documentation, like you have the PDFs. So there is a, with OpenAI, they also have the embedding API. So you can take a large document that exceeds 25,000 tokens, make it into an embedding table, and pass that in.
Yes.
Is that accessible through Azure OpenAI API?
There is an embedding API, yeah. And we just have a like a new feature for cognitive services. I just mentioned for cognitive search. So that one can also use it as a, so before it's like used as a like a full text search engine, and now it's also can do the vector as a vector database, right? So you can use either the one of the model like to do an embedding, save it in the, so you can save both the text and the vector, and then you can even do a hybrid search.
So for the source code, you can see this link. I'm going to share all the link at the end, but my colleague's going to show you another demo.
Sure. So thank you. So there is another use case, call center use case. So the OpenAI here is what we can do is, for example, if there is a conversation between a like agent and customer, so we want to do some like real-time analysis. So in that case, it can actually help the agent to kind of make the customer more like more like satisfied. For example, it can find the useful information more quickly. So this is like the architecture. So by just, as I think I mentioned this earlier, by just using OpenAI, we cannot, like, it cannot use the audio file as input. So here we use this called speech-to-text service, which is also part of cognitive services. So it can kind of convert the conversation on these audio files in the near real time, and then like fit into the OpenAI model. So it can do a lot of things. For example, it can like tell the agent what is the customer sentiment at the near real time, and also it can get the answer much quick. And also it can quickly extract give a summary to the caller, or even it can generate what is going to respond to the caller for the next for the current question. So I'm going to actually show a demo quickly to see how we can use this OpenAI model to achieve multiple things.
One question.
Yes.
You mentioned near real time. So what are we talking like on a response rate for like or converting speech to text? What is the?
So I guess depends on your architecture, you know, the way that you so we are talking about like different services, right? We'd be pairing up together. If it depends on your architecture. If your architecture is it can scale, I guess near real time will be like.
So the threshold I've heard was 60 seconds or less.
That 60
seconds greater than 60 seconds to like 5 minutes is like near real time. I mean, it really depends on who you ask. I've heard anything greater than 60 seconds is near real time, up to whatever threshold that is.
I guess we can talk after the call, because it's like we have to see like what use cases you're looking for, right? Like it's like a real time, because we have like real time services in Azure that they're different, but this is different.
I just hear every time I hear near real time, I'm thinking 60 seconds.
Right. No, it's probably more than that, but you go.
So
we can talk after.
Yeah, let's talk about offline. So I'm currently showing a demo. This is like a call center example. So this is like the call center report looked by the call center manager. So before, as you can see, this this KPI, so its answer rate is lower than the goal, and we have a large volume and have a large like abandon rate. So I'm going to actually show this, although this is like a recording, but it can actually show you. So before, like this is like the transcript between the customer and the agent, and we have a very low like satisfaction scores. But let's see if we use OpenAI, what can achieve in the like near real time can help the agent to better answer the call. So I'm going to play this. So you can see
Thank you
this.
for calling assistance. This is Nina Jones. How may I assist you?
So this is like OpenAI can based on the conversation and give the suggestion for the agent, which can better answer the next question. And also it's able to detect the sentiment, and all this conversation will be converted to the text and send it to the backend.
So I should be. Can you replay this again? Sorry, we lost you.
Sure.
Please stay inside your truck and keep your seatbelt on until help arrives. I'll check our network of dealers and service providers near your location and find the best option for you. Please stay on the line while I do that. Okay, good news. I found a nearby dealer who can send a repair truck to your location within an hour. They will also tow your truck to the shop if needed.
Thank you so much, Mina. You're a lifesaver.
You're very welcome, Brent, and hope things get resolved shortly. Bye now.
So here we use a couple of couple of use cases in OpenAI. It's like content generation. So it can, based on the conversation, kind of generate a response for the agent. Also, it can do a sentiment analysis, and it's able to detect the customers, whether it's from negative to very positive. So it can generate that by answer every single questions. Also, it's able to kind of summarize this conversation. So let's also take a look. If I send this to the application. So this is like the script. After the script has been generated, we can also ask some like summarization questions. So for example, let's ask a list of questions here, and let's ask it to generate a summary.
Question.
So, go ahead, please.
That's a real person right now. Ladies.
They're asking that that's a real person, or is that just the AI machine's voice?
That is a real person. That is the agent. So this AI is helping the agent to better answer the question.
But you can replace it with AI created voices, right? They can just read the script.
You can, if you want to use that, you may use a chatbot. So there is another service called text to speech. And if you want to add additional layers, like you can convert that AI generated content actually to the speech. Yeah.
Can you replay this again, please?
I did have a question. So you guys.
You want to replay that? Okay.
Yes.
Yeah. Let me quickly.
That's a question for me, or?
He's asking over there.
Okay.
Go ahead.
Yeah, I think the ask is.
Any question? So you have a question?
I did. So you have the text to speech, and as we do images with cameras, we can identify the, I guess, satisfactory or happiness or facial expressions, right?
Yeah.
Do we have tonation yet based on text? We have text, but do we have tonation of that speech as well yet? Does that make sense? Because I can use text all day long, but you may not have the same tonation of that person's satisfactory.
So they saying basically, can it detect it from the tone of their voice, not just the words they say?
Inflection of the voice.
Volume, inflection.
I can be a variable, miserable person with my words, but a very happy person at the same time.
In the speech kind of models, today is able to identify the voice. For example, you can tell this who is speaking, so it can actually identify who is talking. But I don't think that model, like whether based on the tone, tell you the sentiment.
I know that the other way around is possible. You can actually put intonation for like make it angry, praise, or angry. But I didn't know that the other way around. I haven't seen it myself.
No, I was just curious if we have that yet.
We don't have it yet.
We don't have it released yet, but that today that is actually possible.
Say that again.
I mean, that is possible, so, but there's no like released.
The only reason I'm asking is because when we use different languages, and especially when we start having a lot of people talk, particularly in the English language, we have a tendency of using words that may not necessarily reflect what we're talking about.
Right. No, I understand
that often, but that same, but that dialect will show it a lot better.
I haven't seen the models, but again, like my colleague, I share the same feeling. It's not far from from imagination, especially because we already have the facial sentiment detection, and we have like the language part. We just don't have the tone. Maybe that's a little bit more complicated, but it's not far from.
Yeah, just one quick question. So is the value proposition here, this use case, is AI offering suggestions as they're having this conversation? That's
So,
okay.
yeah, the suggestions, and also it can help you to answer the question. So for example, if the user asks about, let's see, about his insurance, so the agent, if the agent has a portal, maybe it need to tap it. But using the large language model, we can like directly connect to the database, convert that natural language question into a query, get the answer for you, and have that suggestion to the agent. So the agent doesn't need to like find the answer.
So today, if any call center, they would just basically have some bunch of text, like they just read from the same text. So it's like the answers would be like a generic. So I would personally don't like that. That's why I was like, I don't like just generic answer. So this will give you like nuances, like and more relevant answer. And things that maybe the agent doesn't know, but AI has access to all of the other information.
With some latency, right? There's going to be some latency.
Right.
Okay.
And also there's some tools called like it can generate user summary. And what I'm going to show is, let's see if we want to automate this process, like automatically convert the audio conversation into like machine readable information and add it to the downstream services or database. So it is able to generate it like into like a JSON format and capture all those key value pairs. So with this information, we can directly have like a workflow, have a pipeline to add this call to the database. So that's also
So in an emergency situation, is it going to pick up on a lot of background noise? Because usually it's really loud, things are going on. Is that something that's going to pick up on and
those problems
Hog as well?
Like removing the background noise, that should not be an issue. That's a problem itself for AI.
Yes.
I had a question on like the healthcare example.
Yes.
Is there like a higher token limit with Azure to train the model on?
Yeah, so the generally speaking, the GPT-4 has a higher token, as a double token limit than the GPT-3.5.
Right.
I don't have access to that was GPT-3.5, by the way. I don't have access to the GPT-4. Is it like those requires very expensive hardware, and some people have access to it, some customers. But what I was trying to say is that we don't need the higher token limit, because what we can do, we can chunk up the size of the inputs using the cognitive search. So you don't essentially eliminate the limit, because any limit you can imagine, like let's say like I don't know 50,000 words, right? 50,000 token, which is different than words. But anyway, any limitation when you have like hundreds of pages. So that IMF report that was actually a combination of 2-3 reports. It was 1,200 pages. So you cannot give 1,200 pages to the input. That's not feasible. But what you can do with the vector databases and embeddings, you can actually find the most relevant chunks and feed only those to the inputs, and then you get the result back, which is even going to be even better, even more accurate. So for example, the Bing search, there is no way you can feed the entire search to the ChatGPT. There is no way. It's just like, we talk about like millions of pages, right? That's not possible. But what Bing does, it will rank those pages. That's the same thing that the Google does. So those rankings, but the top rankings based on what you're searching, you're gonna give like maybe like, I don't know, 20 first results. And that's exactly, by the way, what you do when you search the web. What do you do? Like you go first page, second page in Google, like, and then third page maximum. You don't go to the page 1 million, right? Just only search like the first 3-4 pages. That's exactly what it does.
So there's a weight assigned to the content that.
But that's vector database. Exactly.
Oh, okay.
That's it.
So I do have a question, and this is not necessarily Bing or Google or any of them. As we do search, is there a mechanism from the UI that will allow us to, as humans, do the error checking for the, I guess, results. Because in some cases, not using the right false positives, but we know that I've Googled, I've Binged, I've whatever, and the information that comes back is not relevant. And it's not relevant because it doesn't fit that parameter exactly. Is there a way that in the process that we can give feedback as a human that has the knowledge or the error checking that then allows that model to not necessarily retrain, but then error correct, so that way the next one, you know, works more closely with that information?
Yes, that's a good question. So for example, when we design a like enterprise application, so usually we're gonna design like a validation set. So the SME is gonna design that. So because your first version of prompt will not be perfect, you need to like tune that prompt, doing prompt engineering to make that better and better. So that validation data set will start with a category, a couple of categories. Each category will have a list of questions, and later on you may use the questions as examples and include in the prompt. We call it few shots. That is like give you these examples, and then later, if you have similar questions, you can extract the right fields, or you can kind of answer the question using that examples. Yeah, and yeah, for sure, those can be also designed or like enabled on UI. So when they ask a question, if it's like the answer is not accurate, so the SME can label that, so that can go back to the database that's used for the we don't call it fine tuning, but it's like to do the prompt engineering.
By the way, this is the same exact thing that the people in OpenAI use. They use like this little by little improvement on the foundation.
Yeah, like fine tuning the
base models.
Yeah, the base model.
When you talk about correcting the model little by little, like he was saying in the example, you have an incorrect answer, and then you improve the model little by little. How many iterations do you have to go through? Are we talking about 10 is enough? I think it's a couple thousand, right?
You don't need that. So now it's like a even we want to give a prompt, it's like we call it a few shots. So a real example is so for example, so we design like a prompt to let it generate some like cognitive search query that's able to query a relational database. So usually after we give like 12 or 13 examples, it is able to understand something like, for example, if I ask a question, can you give me a list of products that the certificate will expire in the next 3 months, for example. So in that case, it's able to gather today's date, calculate like 3 months long, and give you the queries less than like, for example, September 30 is greater than like July 1st, and generate that query correctly. Yeah, it's just a few examples should be enough.
So one more thing I should add is that when we talk about like improving, we don't retrain the model. The model, it takes years to train it. We don't retrain it. It's not like the regular ML model to give it a new data set and retrain it like an hour or two. It's not like that. We improving the meta prompt. So we just basically changing some parameters. These models are huge, ginormous. You cannot just retrain them.
Okay, yeah,
Right.
That helps a lot. Thanks.
I have a question. So once these embeddings are created, are they migrated from model to model, or how do you treat?
So if you, for example, if you do a GPT 3.5, if you do like a prompt engineer, if you do embedding, if it's go to GPT-4, unfortunately, you need to do that again.
Okay, so
the base model are different.
Sure.
Yeah.
Now, are the embeddings any different between cognitive search versus just the vanilla OpenAI?
The cognitive search, you mean the Azure OpenAI model?
Yes.
The embedding should be, will not be exactly the same, because it's like a probabilistic model. It's gonna like give you the next word by, but it should be like, because the base model is the same, so the answer should be similar. Yeah, but should I would say not exactly the same.
Yep, a couple more surprise demos in up his sleeve. So hopefully we get to it.
So next we are going to talk about this large language model application framework. So how we can build like a powerful application. For example, like if I have a database, can I use this large language model to answer any question? So or if I have ask some question, I want to use the different type of APIs. I want to go to a archive, which is like a scientific like database. They have a lot of publications. I want to like go to that as a knowledge base and answer my question. How we can do that? So this is like we're going to talk about this. You may already use that. It's this large language model frameworks. So there's two popular ones. One is LangChain, which is nice. It's pretty widely used. And Microsoft recently released another one called Semantic Kernel, and my colleague will talk about it soon. So the idea is this comes with what they call like a agent or SKUs or tools. So in that case, you can like create a chain and let this OpenAI model or this large language model as a brain to select which tools I'm going to use and get the right answer. So so I'm going to show a quick example how we can use like we call it like a GPT search. So it can not only search for the knowledge database, but also can search from the like relational database, or you can kind of upload a CSV. So I think we are running a little bit running out of the time. So I'm already run this. I'll directly show this, right? So in this case, this is like we call it Azure Search Engine. So the backend behind this is a GPT model plus a LangChain. So we have enabled a couple of tools. So we enable the Bing API. We have the SQL agent. So this can connect to a SQL Server database and trying to answer the question. We also have the doc search. So this will connect to a cognitive search knowledge base. And we also have that like ChatGPT model. Of course, we can enable more like tools here. So in that case, when we ask a question, it will try to figure out which tool I'm going to use. So for example, if I'm asked a question about what is the weather in Houston today. So in that case, because this model like is trained a couple months ago, or, like so it doesn't have that latest news. So it's going to go to the Bing, trying to get the latest information, summarize on that. If I ask a question about can you find some information from the archive, which is like the publication like database, to tell me like what algorithms today can be used for the stock price prediction. So this will be performed as a doc search, which Cyber showed earlier. It's going to search for the documents and trying to grab the right paragraphs and trying to summarize on that. Or if I ask a question about like about a database. So this is actually will connect to a database and trying to figure out what queries it's gonna use at the so let's focus on the thought process on the right-hand side, and I'm going to show this example. So what I'm asking for the last question is, so I do have a database. As you see here, it lists all the tables is in the SQL Server. It has a bunch of random tables and also have some like invoice information and customer information. So I asked the question is, can you tell me who are the top 3 customer by purchase amount? So no additional information. And then this LangChain agent is trying to figure out which table is going to use and which column is going to select, and then like what query is going to write. So if you look at that action step by step. So first is trying to grab all the available tables, and then second is trying to find the potential like relevant table and trying to get some sample data. Whether I find some customer name, whether I find some like price information related to a product, and after that is trying to generate a SQL query and trying to execute that. So here it's got some sample rows from the table, and then it's generate a query. And this query is actually joins a customer table with the invoice table, and then trying to generate and also it has a group by function and get us the top 3 customers, and then it's going to summarize based on the final output and give you the 3 names for the top 3 customers.
You're not using a vector database in the middle of this?
This one, no, this is not a vector database.
Just going direct.
This is like SQL.
You're going direct to SQL, not no vector.
Yeah, so that is a SQL search tool. So if I do a doc search, right, so above that, so this is similar as the demo Cypher showed. So I asked the question, can you give me a description of the stock price algorithms, prediction algorithms? So it's going to go to another database, trying to grab a couple of PDFs, summarize on that, give you the results. Similarly, if you want to have a CSV file, right? So I have a CSV or Excel file. I want to ask some question on that, we can have another tool here to load the CSV and trying to let it. So it's like write some like Python Panda functions for you to get the answer. Yes.
This, to connect to this database, does it utilize, so as the OpenAI service has its own managed identity in Azure that it can be created as an external user?
This uses a framework called long chain. So that long chain is like an agent. So agent will determine this question, I need to look into the database. So then it will, using the SQL server, like ODBC connector, connect to the database. And the large language model here, this is a thought process, is just to run a bunch of queries and step by step to figure out which query is going to run and get you the answers.
This is an application. It's not an OpenAI service. This is an application that is happened to be orchestrator of, happen to use the foundation model, in this case, OpenAI.
I think the assumption here is that your database is structured correctly, like, or are you going to educate it about your tables and your schema?
You mean, yeah. So this agent is gonna, we can set like a parameter called iteration. It will try. So for example, the first time it may not grab the right table, and may not generate the correct SQL query, and then it will go back to the steps where it makes error and trying to correct it. So it will try a couple of iterations. But as a ChatGPT, you can always provide more information to guide it to get the right answer for you.
So it goes back to the same thing we talked about, like improving this. So for example, if you name some table like something weird, you can train it in advance that, okay, if someone asks about customer's table, this CTREL table, that's like it's a customer table, and it knows.
So there's one thing I didn't show. So I think ask question about like, can we analyze a CSV or like Excel, right? So in that case, similar, we can have an agent or a tool as like a CSV tool. So in that case, we can load the CSV files, ask a question. So the logic behind is going to generate some like, for example, if I use Panda, if I use Python, it's going to generate some Panda code trying to get the answer from the CSV file. Yeah, similar logic.
I don't know if it's just me that, these days, we drive like automatic cars. Back in when I learned, we use manual cars, but future people, they don't even know how to drive because self-driving cars. Same thing about this one, you'll never know how to write SQL queries. It's gonna make me sad.
Let's see.
So one of the questions I have is around more, less around the functionality but more around when we start talking about data access. So while the agent is running and querying and doing those types of things, we have the ability in SQL, in Power BI, and a lot of things where we can do row-based access, things of that nature. Is there ways in your tools to recognize the IDP token of the user to then pass that off to the actual agent to recognize that the data that's being accessed or being delivered back, that it's not the access that the ChatGPT has to, but what the end user should have access to? So where we have a zero trust model, we actually have an engine in between that actually still works within the framework of our IDP.
That's a great question. I think it should be, and I believe Microsoft is working on it, because I've seen some demos like they're working on security Copilot. I'm pretty sure they come up with something like that very soon. But that's a great question, and I think I agree with you. There should be something like that.
All right. So next I'm gonna pass to
sure.
Cypher for the.
So my colleague showed the LangChain, and LangChain is very popular. What I'm going to show you is a semantic kernel. So all of these Copilot stack that you've seen, so Microsoft internally been developing the Copilot stack using the semantic kernel. So the semantic kernel, for those of you who are .NET developers like me, who feel like left out, they have to learn. I'm learning Python, but the semantic kernel has Python and has also .NET SDK. So that's great news for .NET developers. So the semantic kernel is the tool that essentially Microsoft developed internally for themselves for developing all these copilots, and it's using the copilot stack that I was introducing you. So it has bunch of features. There's a kernel, right? And the kernel is like, you can think of it as a core of it, and there's skills that you can add to it. And I'll demonstrate some of these skills. You can think of these skills as either a semantic skill or native skills. You can add like native Python or C# code to it, and it will do stuff for you. There's a planner that essentially, like, let's say you're loading 10 extension or 150 extensions. It knows which one to pick for which job. So that's the planner. And there is memories. Memories essentially utilizing the vector databases for different things. I will demonstrate that for you. So I have an open repository here, which is on GitHub. You can access to it. It's a fork from John Maida, which is our VP for the AI. It's called Semantic Kernel Recipes. It's actually pretty cool. It has a lot of step-by-step notebooks. These are Jupyter notebooks, by the way. These are meant to be for the Python, but there is a .NET interactive kernel for it, so you can actually run .NET code in these Jupyter notebooks. So this is in GitHub Copilot running .NET interactive in the Jupyter notebook. The 3 demos that I want to show you. The first one that I think I'm going to start with, the most impressive one, is the design chain. So this design chain. Remember that call center demo that my colleague showed you? So you can actually do that, all of that with semantic kernel. So you can see that this is actually C# code. I'm running this code. It's installing the preview version of semantic kernel NuGet package. It's essentially C# code. It's like building the kernel. So this is like an iKernel building the kernel. I happen to use the OpenAI model, but I can use Azure OpenAI. It's this very similar thing. It's a DaVinci model that I'm using. So here, what I'm going to do, I'm actually getting this information from the call center. So it says like there are 8 customers. They're coming from. They're basically talking about the way that the support works or the product. So there are a bunch of statements. You can think of it as thousands of records, right? And the first thing it ran. We basically ran a skill called empathize. So we start from empathize, then it goes to the define, ideate, and prototype and testing. So empathize, it's basically all it's doing is basically saying that, okay, these are my input. So what is the skill that I'm using, empathize? So I can demonstrate this for you quickly. So all it is, it's just basically this. If I can make it a little bit bigger here. So it's basically saying the following anonymized comments from the customers, and this is the input. You can have multiple inputs, and please isolate the three most common learning moments from these and put it as a JSON array, and that's exactly what it does. So it's just doing that, right? And then I'm taking that input and giving it to another skill, which is very similar to that one. It's called defining. So I want to define the problem now. I'm not just going to sympathize. I'm going to define these problems. So when I define these problems, I'm basically categorizing all this into the top to the bottom issues, and then while it's running, I can show you the define as well. So very similarly, it's just the text that says, just basically define the 5 most likely related problems, and then give it a title and the name, right? And then at last but not least, we want to ideate these problems. It says, these are the set of problems, right, that are coming from the definition that we just got. please, in a markdown table, make it 2 columns labeled as low-hanging fruit and high-hanging fruit. And the low-hanging fruit is like easier to medium level of execution required, and then high-hanging fruit for like a lot of resources needed, right? And it will do just that. So if we go back and give this one to the next model, you see that the result is going to be essentially a markdown table. But this is not good for us, right? So why do we just put a little like .NET sprinkle on top of it? We use the MarkDig and other NuGet packages from C# and get a nice looking table, right? HTML table that says essentially all of those calls from customers went to the semantic kernel, and this comes out of it. So this is all using the semantic kernel. So the next demo I have for you is using native skills. So this native skills, essentially, what I'm going to do, I'm going to use Bing API. I can use Google API. There is actually a built-in Google API as well here. So this one is basically saying that let's search the web, right? Let's search the web for something like what is the tallest building in South America, right? Now I want to combine the skill of what I showed you, the skill, remember those semantic skills, just the text, with the native skill. In this case, is a Bing search, which is essentially like just it's a C# code, right? That calls Bing API, get the information back. I'm going to combine them, mix and match them together. So basically asking and give it to the search. So this first result is going to be purely from the native skill. The second one, I'm going to give the native result to, I'm chaining it. This is a command chain pattern. I can chain them up to the semantic skill, which is a summarize. So now that Bing search is going to be like probably like a long list. Give it to the summarize skill, which all it is essentially just summarizes for us. And there's a note generation skill as well. So the result is going to be like this. So what's the tallest building in America? Bing answer is going to be, it's too long. I have to scroll, right? But the summary is going to be shorter, and notes is going to be even shorter. And those summary and notes are similar to the semantic skill that I showed earlier. And the last one is this memory thing, which is using these tokens and the vector databases. So in this case, it's actually using in-memory store database, but it works with Cosmos DB, it works with the semantic search, it works with a lot of open source vector databases. There's this built-in connectors for it. So essentially, like add the memory, the way that the brain works. You just add the memories, like let's say, like LinkedIn bio, LinkedIn history, recent Facebook post, and when you add all that, you come up with the 4 gigantic vectors. You can think of it like thousands of dimensions, right, of vectors, and these vectors have different properties. And when you ask for someone, say, describe me in less than 70 characters, it gives you a generic answer because it doesn't know anything about you. It just say a professional, right? It might as well be wrong, right? But when you give it the memory, it now knows a little bit about you, and it picks the right memory, and essentially like look at your bio, look at your history, and it gives you the answer more accurately. So that's all the demos that I have. So let me close it up. Any questions? Yes, sir.
All right, nothing to do with Azure at all. A lot of these prompts are very creative. Do you have any tips for?
Yes.
Like
lower the temperature.
But like, I mean, oh goodness. If you reach into your mind, you'll find the perfect prompt. But I like that one demo you had where you had a bunch of middle that said what my thought process was. Is there like something in most of these language models where they will explain why? Because what I've done is I've done a lot of image generation, and I can tell I have typed a perfect prompt. I promise you it's perfect, and I get garbage on the other side. And so I need to see something is going wrong. And I've even seen the Stable Diffusion has the reverse, where you show it a picture and it says, this is what I see out of it. It seems like the prompts don't match up with reality. So any tips for like?
So where do you specifically give this prompt to again? Sorry.
A bunch of things, everything. DALL-E.
Are you using OpenAI or just ChatGPT?
ChatGPT, it's just a little bit everything. I've seen the same problem where it seems to understand some words, it doesn't others, and I'm not using vocabulary words, just.
Okay.
Yeah. So I'm just curious if there's ways to help with that middle step of like making it less of a black box.
Right, take that.
Wait 2 years, come back.
So there is like some recommendation I can share. So it's like some approach for prompt engineering.
Yeah.
So yeah, we can also share some like training documents on that. Well, one approach is you can chain your prompt like step by step.
Okay.
So break like a large prompt into pieces. So in that case, step by step, you can see what at which step that prompt is not good enough. That's one approach.
Also, if it's just some randomness, I was actually serious about lowering the temperature. So if it's just so many randomness, you can actually lower the temperature, and that's exactly what it does. It gives you a little bit less creative answer.
Okay.
Bing has that like less creative, more creative feature built in, but you have to fine tune. Oh, one more thing, actually, cool, good that you mentioned it. All of these prompts, they has a JSON configuration attached to it. You can configure fine details of how you want it to be. So, for example, you can set the temperature and top P and other settings. So yes.
Are your fees for the language model the same as OpenAI's, cheaper, more expensive? You know, like the language model fees that the OpenAI charges?
Oh, the pricing
for the tokens, I think it is.
Oh, the pricing for different models.
Yeah, is your pricing the same or different?
So I know that you can add to. So I know that there are different models. They have different prices. So technically, the more advanced or the more sophisticated the model is, the higher the price is. But sometimes you don't even need.
Let me ask it a different way. If I use GPT-3.5 over an OpenAI, and I use GPT-3.5 on your side, are the charges the same for the tokens, or are they different?
I think it should be each one is more expensive. I don't know, to be honest.
I think it would be different based on because you're also going to be using cloud services to host all of your applications on Azure, so it will all come up. You'll be surprised.
But what I'm saying is that
they're going to mark it up 3 times, you're saying?
Oh, yeah, probably.
What I'm trying to say is that
3x.
so sometimes you don't need to pay for those expensive models. One of the cool thing about Azure is it gives you choices. So you have actually different models you can deploy and you can pick the model. For OpenAI, it's just one endpoint. You just pay for one endpoint. There is all the models it's a charge the same rate. But in Azure, you for example, if you use Ada is lesser price, for example, to compare to DaVinci models, because DaVinci models is more expensive. DaVinci model is the most sophisticated, right? And there's a code version, there's different version. When you use something like a GPT, like ChatGPT, that's a blended rate because it uses different models, depends on what you put in.
I apologize. I was trying to use your API. I couldn't even get access.
Well, it's the same thing. I'm
open APIs. You see, they have a price structure. I couldn't tell when I went to.
That's what I'm trying to explain. So it depends on what you want to do. The price is going to be different in Azure OpenAI Service.
So for example, if you want to do a sentiment analysis, you don't need to go to the DaVinci model.
Right.
Because that will consume more tokens. It will charge more. To do a classification, sentiment analysis, probably you can just do it using an ADA model. So that will charge you less because it consumes less tokens.
No, I understand. I was just asking model to model is the same price. I buy an apple here and I buy an apple there, same price.
So this is what I was talking about. If you look at this one more, there's a huge difference in terms of pricing. What my colleague was trying to say is that if you was, for example, do the sentiment analysis, you don't have to go to the DaVinci because DaVinci charge you 10 cents per query. But you can use the cheaper model, like that's I don't know that's not even a penny. It's like a four.
But that's cool. You got your pricing up there now. I hadn't seen that before.
So yeah, they're different pricing, depends on what you want to do.
Okay, thank you.
I have a fun question. What's your favorite specific use case for large language? Like not the ChatGPT,
Right.
like the specific. What have y'all seen that you're allowed to share?
For me, is a Copilot. And Copilot is a game changer. If you haven't used it, please do, because it's like that stuff is black magic. I mean, for me, it is, because it's like, I give you an example. I literally got a code, like, from customer. I mean, I can read code, right? I've been developing code for many, many years, but it takes time, you know, it takes cycles. So you just put it there, just please fix this code. There's an error. It will fix it and it will explain it for you. Sometimes it doesn't fix it and you say, okay, it doesn't work. I'm saying, I apologize. This is the fix, and it fixes it. So it's just gonna give you a minute instead of like an hour or two to fix that code. So that stuff is my favorite.
Also use that for some data science like Python code. It also works perfect. So
it's awesome.
So if I'm using Power BI and I want to write some Python code, you know, to take care of my data in Power BI, is this been incorporated into Power BI? So all I can do is just tell it what I want it to do and it'll write the code for me?
For Power BI, I think there's like a Microsoft 365 pilot for each of the
Okay, there's a pilot for that.
Yeah, so we didn't have access to that, but I do see that it can generate the PDF output for you. So,
With like a sustainability push that everybody's kind of in companies now doing ESG reporting, how are a lot of the companies that you've kind of shown on the board that are already using this actually demonstrating that they're using this responsibly and sustainably in a way that kind of allows them to meet net zero goals and these kind of things? Because I imagine if you incorporate this into a call center of a couple of hundred people, all of a sudden your scope 3 emissions are going to start shooting through the roof. So how are companies now starting to, or is it all just about greenwashing and, you know, paying for a new field somewhere?
So obviously the way that they manage, I mean, for Microsoft, I know that they have like an open statement about the commitment to the sustainability and zero emission, all that stuff. So every company has a different goal. I guess you have to ask them. But how they're using specifically OpenAI for that. So I guess technically speaking, OpenAI is hosted by Azure, Microsoft. So since Microsoft's committed, so
if I wanted to get kind of my energy usage, my kind of like total consumption, shall we say, out of Azure for all of the models, all of the things that I'm kind of now suddenly generating as my kind of scope 3. I know kind of currently to do it for like APIs and things like this. It's not the easiest thing to be kind of doing is working out all of this kind of stuff. So what is it now that kind of companies are falling back on to basically say, actually, we're using this sustainably, we're using this responsibly? Because I know that AI in general is a very hot topic in sustainability. So how are you kind of, you've demonstrated lots of things that are going to lots of processing power. You started by saying in 2017, we didn't have the hardware for this. So clearly we need more and more hardware to be thrown at those kind of things. So how is it that we can kind of...
So I can tell you what Microsoft does for the data center. That they literally building the data centers with zero emission, and the way they do it in each location, they have like a unique solution implemented. So for example, in Germany, they don't have a lot of sunshine, but they use other energy sources from the ground or from other energy sources. From some places that are a lot of sunshine, they use solar power. For other places like, well, I mean, Texas has a lot of sun for sure. We can use solar power here, or even.
That would fall into like demand shifting and stuff like this, though, wouldn't it? It'd be demand shaping or whatever you think it is. It effectively says we will use AI and things when we have renewable energy kind of available to us. But there's no tool like that in Microsoft at the moment where I could say.
I think there is actually.
So Power BI, there is a sustainability dashboard, but I don't know how easy it is to wire. I've tried wiring up to things.
So you're talking about specifically about this because Microsoft has an open statement for the goal of like zero emission, and I think they're even gonna go carbon negative. So they're gonna pump more carbon. I don't know how they're gonna do that, but they pump more carbon out of atmosphere that they put in. So I don't know, to be honest. I'm not the best person to ask about it. Yeah, any other questions? So yeah, these are some of the customers. And if you want to learn more about these things, so these are the demos that we showed for the LangChain and semantic kernel. You can take a picture of this screen, and also if you want to get an access, go to OAI/access.
You guys go back.
Go back one.
Yes.
You still have to have special access permissions to get in.
Oh yeah, and
By invite only.
Please believe me, we don't even access to some of we don't have access to some of the GPT-4 models ourselves. So this stuff is apparently each of those boards costs like 40 grand each board, and NVIDIA has monopoly on it. So. Yeah, that's it.
We're done. All right. Thanks, guys. So who learned something? Anyone learn something?
That's good.
All right. Well, thanks everyone for coming out. We welcome suggestions as to other topics. If there's anything else that anyone would particularly like to dive into, come and talk to me. But in any event, we'll be back next month. Many thanks for coming out, and hope to see you then.